We're going to find the derivative function by first principles, given that y is equal to 2x squared. Firstly, I like to consider the function y to be fx. So then I shall be able to write that the function at x is equal to 2x squared. And the reason I like using the function at x, because now I can write the function fx at x plus h. Now that's going to be 2x plus h all squared. Defining these 2 points, which will give us the gradient function, is very useful. And now we need to write the derivative function. First, I'll just write the general derivative function. Always write that first. So it's f dash x is equal to, and the most important part is that we are writing the limit as h goes to 0 of function fx plus h minus the function of fx over distance h. And yes, I know that it could be written as dx dy, but I prefer it always to write it as the function with dash x. This is what we call the general formula, and this should be written before you do the workings out of the first principle. So far I've written the function, which is 2x squared, and I've also written the function at x plus h, which I inserted dx. So these two equations should be here, plus the general formula. Now what we're going to do is we're going to substitute these into our general formula. So our derivative function is now going to be, and every time we will write the limit as h approaches 0. And now we will insert the function fx plus h, which is here. So we'll put down that's 2x plus h all squared, and then I take away the original function, which happens to be 2x squared. And now I can divide it by h again. This is a way of expressing a gradient. As h becomes infinitely small, we want to make h equal to 0. So the whole point of now rearranging this is to make sure that we do not have h in the denominator, because if h is 0 in the denominator, then this function is undefined. The next step is to expand this, the numerator. Remember to keep on writing the limit as h goes to 0, and now we expand the top, and that'll be 2x squared plus 2x h plus h squared minus 2x squared, and we divide this all by 8. Now here's a side note, a very important side note, because I have seen so many students expand that top binomial here that's got to be squared into x plus h squared is equal to x squared plus h squared. This is completely wrong. What you should have gotten was this binomial turned into a trinomial. Okay, let's continue expanding. So we'll multiply everything by 2. That'll be 2x squared, 4x h plus 2h squared minus 2x squared, and once again that's all over h. Now we can see that we can cancel out 2x squared here, and we can cancel that 2x squared here. Let's just rewrite this again. We now have just 4xh plus 2h squared over h. Now as h goes to 0, the reason we have been rearranging this is so that we do not have at 0 in the denominator. We must get rid of that h. So one of the ways we can get rid of that h is by taking the h out. This allows me to cancel the two h's, the one in the numerator and the one in the denominator. Now we can't cancel that h over here because that h still stays here. So now the limit as h goes to 0, we make that h 0. So that will be now equal to 4x. Now notice I no longer used that term here, limit as h goes to 0, because I've just made h equal to 0, and all I'm left with is 4x. And this is my differential function. You may want to now write it as dy dx is equal to 4x. Either way, this is going to give you a mark, the answer. The method itself is also going to give you a mark, and the fact that you wrote the general formula is giving you the third mark. There are 3 marks in here. Now guys, I'd like to tell you that this question was one of the easier differentiation questions, because there are 3 types of differentiation questions that you need to prepare by first principles. One of them are normal functions like polynomials, and this is a normal polynomial, so it's not too hard to do it by first principles. The other type are the reciprocal functions, and the third type are the roots, and you'll have to multiply by conjugates, which is a little bit harder. So I intend to do a few more of these differentiations by first principles of the other 2 types. So please subscribe to this channel so that you can follow these problems, and also please give me a thumbs up. Of course, if you have a problem that you would like me to solve, put it in the comments and I'll be happy to solve it for you as soon as possible.